Hi, everyone. My name is Autumn Shackelford, and I am a third-year graduate student working under Dr. Carrie Donaldson-Hanna at the University of Central Florida. And I'll be talking about my research on the morphological characterization of regolith breakdown due to water ice. So we know that thermal studies of the lunar poles have shown distinct trends of increasing reflectance with decreasing temperatures, and this suggests that the regolith present at the lunar poles is unique, namely from the presence of volatiles such as H2O, water, increased regolith porosity and fairy castle-like structures within the permanently shadowed regions show that the weathering processes occurring at the poles could also be unique. So my advisor and I decided to investigate the morphological changes and spectral changes, though none of those data are presented here today, of Exolith Labs' Lunar Highland and Lunar Mare simulants, LHS1 and LMS1, respectively, when they are mixed with various concentrations of water ice. So to do this, we mix regolith simulant with different water concentrations and freeze it for varying periods of time. And after the designated time is up, we bake off the samples and begin our analysis. We have used a camera-wielding microscope alongside some designated image processing software to address changes in individual particle sphericity and elongation, as shown in the bottom right of this slide. We also employ scanning electron microscopy to further characterize the weathering of the samples when it comes to fine particulates, because those are much harder to image, as you can imagine. So from these data sets, we see distinct, predictable trends in how the Mare simulant weathers. We see increasing sphericity of the particles and decreasing elongation of the particles with increasing concentrations of water, which is what you would expect when things are weathering, when things are like eroding and things. However, the Highland simulant seems to weather without regard to the amount of water added. In these SEM images here at the bottom of the Mare simulant LMS1, I would like to highlight the increase in clumping and number of fines between the two images. The image on the left is simulant with no water added, and then with 38% of water added on the right. And yeah, you can kind of see there some of the changes that we're seeing. Soon, we hope to obtain electron dispersive spectroscopy measurements of the samples to characterize which mineral phases are actually breaking down in order to clarify the discrepancy in weathering between the two simulants. We also plan to continue taking spectra in the VNIR and the TIR to further characterize the weathering effects. So please come check out my poster. I'd love to talk with you guys in more detail about it.